Imagine a world where everything we know today as continents, America, Europe, Asia, Africa, Oceania, and Antarctica, did not exist as separate entities. Instead, Earth was dominated by a single massive landmass, surrounded by a vast ocean. This is not a fantasy scenario, but the reality from hundreds of millions of years ago. This is the story of the supercontinents, the forgotten giants that shaped the planet we know. Over 1 billion years ago, Earth was in constant change. The tectonic plates, those immense sections of the Earth's crust that float on the mantle, began a slow and continuous geological dance. This movement, imperceptible to us, is what united and separated continents in cycles that span hundreds of millions of years. Rodinia, Gondwana, and Pangea are names that belong to this distant past, marking eras when Earth was dominated by a single continental mass. But what does all of this mean? Why is it important to understand how these supercontinents formed and disappeared? The answer lies in the profound impact they had on climate, biodiversity, and the evolution of life on the planet. What seemed like a random configuration of Earth was, in fact, the driving force behind great extinctions, new ecosystems, and global climate changes. In this video, we will travel back in time to discover how these supercontinents shaped the history of Earth. We will see the impact of Rodinia, explore the majesty of Pangea, and wonder what could happen in the future. The history of Earth is much larger than we can imagine. To understand the history of supercontinents, we must first understand what they are and how they influence Earth's dynamics. A supercontinent is, as the name suggests, a massive landmass that groups most or all of today's continents into a single unit. However, unlike what we might imagine, this configuration is not permanent. Earth, thanks to the constant movement of tectonic plates, goes through cycles of supercontinent formation and breakup throughout its geological history. Tectonic plates are fragments of the Earth's crust that move over the upper mantle, a partially molten material that acts like a conveyor belt. This slow movement, of just a few centimeters per year, is responsible for phenomena such as earthquakes, mountain formation, and, of course, the creation of supercontinents. One of the most important cycles related to these movements is the so-called Wilson cycle, which describes how oceans open and close while continents join and separate. Rodinia, for example, is one of the first known supercontinents, formed more than 1 billion years ago. Its name, derived from the Russian word meaning homeland, reflects its importance as one of Earth's oldest configurations. Later, Gondwana and Laurasia emerged as key fragments that would give rise to another famous supercontinent, Pangea, which existed around 335 million years ago. But what causes supercontinents to break apart? The answer lies in the internal forces of the planet. In Earth's core, heat generates convection currents that push and pull the tectonic plates. This means that supercontinents are destined to fragment, creating space for new oceans and landscapes. It's an endless process, a dance that has shaped Earth's geography since its formation. Understanding what a supercontinent is not only reveals the planet's past, but also allows us to appreciate its constant evolution. This cycle of creation and destruction is a reminder that Earth is alive, always in motion, and that changes that seem slow today are responsible for the greatest transformations over millions of years. Among all the supercontinents that have existed, Pangea stands out as the most well-known and studied. This terrestrial colossus formed about 335 million years ago, during the Carboniferous period, and remained united for over 160 million years. Its creation was not a sudden event, but the result of a long process of tectonic collisions that brought together different landmasses into a single giant land block. The formation of Pangea began when the continents we now know as North America, South America, Africa, Europe, and Asia slowly moved toward the center of the planet. This movement was driven by plate tectonics, which caused the closure of pre-existing oceans, such as the Riko Ocean and the Iapetus Ocean. The plates collided with such force that they generated enormous mountain chains, similar to today's Himalayas, like the Appalachian Mountains in North America. The configuration of Pangea completely transformed the global climate. The vast landmass meant that many interior areas were far from the coasts, making them arid and extreme in temperature. Meanwhile, coastal areas experienced a more humid climate, favorable for life. These uneven climatic conditions played a crucial role in the evolution of ecosystems of the time. Pangea not only influenced the climate but also biodiversity. By uniting previously isolated continents, it allowed the migration of species but also led to the extinction of many others unable to adapt to the new environments. For example, at the center of Pangea, the vast desert expanses were hostile environments for many forms of life. However, along the coasts, lush tropical forests developed that would be key in the formation of the coal deposits we use today. Eventually, Pangea began to fragment around 175 million years ago during the Jurassic period, when internal tectonic forces began to separate its plates. This process gave rise to the Atlantic and Indian Oceans and formed the continents we know today. Pangea is not only a symbol of Earth's immense force, but also a window into the past that helps us understand how geological changes directly impact life on the planet. It is a reminder that, although the world we know seems fixed, it is in constant transformation. Supercontinents, such as Pangea and Rodinia, not only altered the planet's geography but also had a profound impact on climate and the evolution of life. These vast landmasses created extreme conditions that defined how species adapted, migrated, or, in many cases, went extinct. In this section, we will explore how these unique configurations affected both Earth's biodiversity and climate patterns. When Pangea formed, the vast size of the supercontinent meant that much of its surface was far from any ocean. This had a direct impact on the climate, as the interior areas experienced arid conditions and extreme temperatures, with hot summers and cold winters. Oceans, which act as climate regulators, were too distant to mitigate these fluctuations. As a result, the heart of Pangea became an immense desert, where life was scarce. On the other hand, coastal regions offered a stark contrast. Here, the climate was more humid and stable, allowing for the development of dense tropical forests. These ecosystems were essential for life at the time, hosting a rich biodiversity that included primitive plants and the first reptiles. These forests also played a crucial role in the formation of coal deposits that are now extracted around the world, marking a direct connection between the geology of the past and the resources we use today. The geological changes associated with supercontinents also triggered mass extinctions. For example, the breakup of Rodinia about 750 million years ago was linked to one of the most extreme ice ages in history, known as Snowball Earth. During this event, nearly the entire planet was covered in ice, leading to the extinction of many species. However, these extinctions also paved the way for the emergence of new forms of life. In addition to the impact on biodiversity, supercontinents affected global climate patterns. Pangea, for example, created a single large ocean current that transported heat and nutrients in a way very different from how today's oceans function. This influenced global temperatures, ocean salinity, and nutrient cycles, directly affecting the evolution of marine life. In the case of Rodinia, its fragmentation allowed for the formation of new oceans and the release of large amounts of carbon dioxide into the atmosphere, a process that warmed the planet and ended the global ice age. This extreme climate change is a reminder of how geological events can transform Earth and alter the conditions for life. The connection between supercontinents, climate, and biodiversity shows us how Earth's geological history is intricately linked to the evolution of life. Every tectonic shift has left an indelible mark on the planet, influencing not only its surface but also the conditions that made life as we know it possible. Long before Pangea dominated Earth's landscape, there was another supercontinent that marked a fundamental era in Earth's history, Rodinia. Formed about 1.3 billion years ago, Rodinia is considered one of the oldest known supercontinents, and its existence had a lasting impact on both the geography and the evolution of life on the planet. Rodinia formed when several continental fragments, which had previously been scattered, slowly came together due to the movement of tectonic plates. While its exact configuration remains a subject of scientific debate, it is believed that Rodinia was centered around what is now Earth's equator, making it an immense landmass surrounded by a single vast ocean known as Mirovaya. Unlike Pangea, which hosted a relatively complex biodiversity, Rodinia existed during a period in Earth's history when life was still in its early stages. The oceans were primarily inhabited by unicellular organisms and some simple multicellular life forms, such as the first algae and sponges. However, despite this biological simplicity, Rodinia played a crucial role in setting the stage for the explosion of life that would occur millions of years later. One of the most significant events associated with Rodinia was its fragmentation, which began about 750 million years ago. This process not only gave rise to new oceans but also triggered one of the most extreme ice ages in Earth's history, known as Snowball Earth. During this period, the entire planet was covered in ice, from the poles to the equator. Although this event led to the extinction of many primitive life forms, it also created the necessary conditions for the emergence of more complex organisms. Moreover, The fragmentation of Rodinia released large amounts of carbon dioxide into the atmosphere, contributing to eventual global warming that ended the Ice Age. This extreme climate change not only transformed the Earth's landscape, but also fueled a biological diversification that marked the beginning of a new era in the evolution of life. Rodinia serves as a reminder of how supercontinents not only shaped Earth's geography, but also created the conditions necessary for life. Its formation and fragmentation were key events that demonstrated the planet's ability to change radically and adapt, paving the way for the rich biodiversity we see today. The history of supercontinents is far from over. Although the current continents seem fixed and familiar, the tectonic forces that have moved them over billions of years are still active, pushing the plates in a slow but unstoppable dance. This movement suggests that, at some point in the future, a new supercontinent will form, radically transforming the planet's geography once again. Scientists have proposed several hypotheses about what the next supercontinent might look like, tentatively known as Pangea Ultima, Pangea, or Nova Pangea, depending on how the continents align. One of the most popular theories, Pangea Ultima, suggests that in about 250 million years, the continents will once again unite into a single landmass, surrounded by a new superocean. The formation of a new supercontinent would have profound implications for climate and biodiversity. As happened with Pangea, the concentration of landmasses could create vast deserts in the interior, while the coasts, rich in resources, would become key points for life. This geographic change would affect ocean currents and wind patterns, altering the global climate in ways we can't fully predict yet. Moreover, a new supercontinent could trigger changes in species evolution. Migration between continents that are currently separated would allow for ecosystem interactions, creating new opportunities for adaptation and diversification. However, it would also pose a challenge for many species unable to withstand the extreme changes in their environment. While the future of the continents is uncertain, what we do know is that the cycle of supercontinent formation and fragmentation will continue. The tectonic forces driving this process are as fundamental to Earth as water or oxygen, and their impact will be as significant in the future as it has been in the past. Thinking about the next supercontinent is not just a scientific speculation, but also a way of reflecting on the immense scale of geological time and how the planet is in constant change. Earth's future will be as dynamic as its past, and this endless cycle will continue shaping the history of life for billions of years. The history of supercontinents shows us that Earth is not a static place. From Rodinia to Pangea, and toward the future with the potential formation of Pangea Ultima, the movement of tectonic plates has continuously transformed the planet's geography, climate, and even life itself. This eternal cycle of creation and destruction is not only an integral part of Earth's dynamics, but also a reminder of the planet's resilience and its ability to adapt and evolve. Throughout this video, we have explored how these massive landmasses have influenced everything, from the extreme climate at the heart of Pangea to the global ice ages during Rodinia's fragmentation. We've seen how these geological changes have shaped biodiversity and formed the landscapes we know today. And while these processes may seem too slow to perceive in a single lifetime, their impact on Earth's history is undeniable. Looking toward the future and contemplating the formation of a new supercontinent invites us to reflect on our place in this vast, dynamic system. As the continents move, our civilization is but a fleeting moment in a cycle that has been ongoing for billions of years. However, understanding these processes connects us with the past and prepares us for a future where change is the only constant. So, the next time you look at a world map, remember that what you see is not permanent. It's just a snapshot in the endless movie of Earth's history, a story that continues to be written beneath our feet.